Welcome in lecture series of electrical installation and practices. In the previous lecture, that is the introductory lecture, the lecture contained objectives of the subject or objectives of the lectures and course outcome or outcome simply. Now today we will see the need of instrument transformer, then measurement of current and energy in high current and high voltage circuit, type of LT current transformer, that is CTs, high voltage CTs and PTs, and substation CT-PT. So these are the outline of today's lecture. So in this lecture, we will discuss about the practices in the power system or electrical installations. So here, this is one circuit. Let the circuit is high current, means the load is in such a way that the current is multiple of 100, or say 100 to 100 ampere is there. Say the load current is equal to 200 ampere. So this 200 ampere is not possible to measure with the help of our ordinary ammeters, and even if the voltage of the circuit is more than 600 volt or 11 kV, again it is not possible to measure the voltage with the help of our lab instruments or voltmeter and ammeter. Generally, the ammeter which we are using in the lab in the range of 0 to 5 ampere, it may be 10 ampere or say 20 ampere maximum. If you want to measure the current more than 20 ampere, we have to use some arrangement that is known as extension of ranges, and extension of range in the current is done with the help of current transformer. Similarly, the lab instrument or lab voltmeter is the range from 0 to 300 volt for the single phase circuit, and for the three phase circuit it is a 600 volt. So if the voltage is more than 600, say for example the voltage is 11 kV, it is not possible to measure the voltage with the help of our ordinary voltmeter. At the same time, we cannot construct the ammeter which can carry the current of 200 ampere, and similarly the voltmeter which can handle up to the 11 kV or 33 kV. So for that purpose, we are using instrument transformer, and the instrument transformer are current transformer. This is the current transformer, and this is the voltage transformer, or it is also called as a potential transformer. The current transformer is going to step down the current from 200 ampere, say it is the current in the secondary of the CT. If the current is 200, let the current is 5 ampere. The meaning is that the CT ratio is 200 by 5 ampere. It means that when the current flows 200 ampere in the load circuit, so this is the primary winding and this is the secondary winding, the construction and operation is similar to the ordinary transformer, but it is specially constructed in such a way that the primary has less number of turns or singly 1 turns, whereas the secondary has large number of turns. So because of large number of turns, the current gets stepped down. So it is the simple transformer which will step down the current to the manageable level. It may be a 5 ampere, it may be a 1 ampere. So in practice, the LTCT, low tension, means up to the 1000 volt or 1100 volt, the CT ratios are like that. It is say 20, it is say 25 by 5 ampere, means when the current in the primary side is 25, it is going to measure 5 ampere. Similarly, 50 by 5, 100 by 5, 200 by 5, and 500 or 600, say 500 by 5 ampere. It means that for this CT, for example, when 50 ampere current in the load circuit, it is going to measure 2.5 ampere. Whereas whatever the ammeters is connected, it is calibrated, or the dial or the signal in such a way that, suppose it is a digital one, like this is the digital ammeter or multifunction meter, which can measure current, voltage, reactive power, power factor, and all these things. The secondary winding is connected to the instrument. Okay, so here this is the current transformer. Similarly, in the voltage transformer, the primary is connected across the load or across the supply, whereas secondary is a step down transformer. It is a step down, simply step down transformer, where the voltage of the secondary is 110 volt. 110 volt. So whatever it may be the voltage, so generally it is 11 kV, means 11,000 volt divided by, means it is the secondary voltage is 110 volt. Suppose it is 33 kV. So 33 kV is the primary voltage and 110 volt is the secondary side. So whatever the voltmeter, it is going to measure 0 to 110 volt, but the range is written as 0 to 11 kV or 0 to 33 kV as per the application. Now similarly, we can measure the wattmeter to measure the power, and that whatever the measured power multiplied by the CT-PT ratio, that will be the actual power in the load circuit. We can connect some relays for the protection purpose. So this is one kind of circuit which may handle more than 100 ampere to 100 ampere or 50 ampere, but the 50 ampere ammeter is not available. Therefore, we have to use the current transformer, which will step down the current to the manageable level that can be handled by our instrument or relay circuit. Similarly, the voltage transformer or potential transformer is used to step down the voltage to the manageable level that can be measured easily with the help of ordinary voltmeter, or it may be connected to the wattmeter or energy meter. So this is some basic circuit for the measurement of current in the high voltage circuit. Now this is one example where 11 kV supply is there and one metering unit is connected to measure the energy. So this is the energy meter. So HT energy meter, no doubt the name is HT energy meter, but it is connected to the low voltage side from the instrument transformer. It is the current transformer here, and this is the potential transformer. See, this is the 11 kV line, and it goes to the primary winding of current transformer, and the secondary, the outgoing terminal is connected with the load. So it may be a load, 11 kV load, and it may be some here transformer is there, and from the transformer LT panels and their distributions are there. So in each phase, one CT is connected, one current transformer is connected. The current transformer has two incoming and outgoing, so there's the two pairs are there. And whereas the secondary side, this is voltage, low voltage side, this is the low current side, where it is going to handle up to the 5 ampere, whereas it may be a 10 ampere, 20 ampere. It is a HT current. 10 ampere current is very high current, and this is from the high voltage side. So 10 ampere, it may be a 20 ampere. Say for example, the current is maximum is 25. So we can use 25 by 5 ampere current transformer, but it is a HT type. HT CTs are there. High voltage CTs are there. Now the voltage transformer or potential transformer PT, it is connected on the high voltage side to the bushing side. The terminals are connected, and whereas the secondary one is connected to the earth, and here the secondary of PT is connected to the meters. So in energy meter, there are total 9 terminals are there, and one terminal is common is connected, and one terminal is connected with the earthing point. So this is the S1, So secondary side of one current transformer, say S1 is there and S2 is here. So this is S1 and S2, secondary of current transformer S1 and S2. Similarly, secondary of second CT for the Y phase, it is connected to S1 is here and this is S2 is here for the second CT and third CT. So 6 terminals are there for the current transformer and 3 terminals are for the potential transformer. So it is going to measure the current in the energy meter. This is going to measure the voltage, and this, and one is the earthing neutral point is connected, and this is the common point. So by this way, we can measure the power, or we can measure the energy with the help of CTPT in high voltage circuit. This is different type of CTs are there. It is called as a ring type current transformer. See here, this is 200 by 5 ampere. This is the rating. Current rating is there. It is a 200 is the primary current and 5 ampere is the secondary current. That is this is the secondary terminal. It may be a S1. This is say S2. And whereas this ring, it is connected in the bus bar. So say this is the bus bar in the panel, or it may be the lead of cable. This is, say this is the bus bar is there, where we are going to insert in the ring type of CT. So this is the ring type CT is connected over the bus bar, and these are the secondary terminal. So this bus bar act as a primary winding, and this is the secondary terminal. It has large number of turns. So it has large number of turns. So it is going to step down the current in the manageable level. Say it is a 5 ampere, whereas the current maximum current rating of the primary is 500 ampere. So it is 200. Okay. So it is, yes, it is a 500. So it is a 500 CTPT. So 500 by 5 ampere. So these are the different size of rings are there for different application. It may be the cable for the different ratings, and bus bars are there. So this is one type of LT. This is the LT, means low tension type. It is, the voltage range is up to the 600 volt. This is one more CT. It is again LTCT, where permanently primary winding is connected with the help of bar, or with the help of bus bar is there. So it is a single CT. Here these two terminals are there for connecting your terminal S1 and S2, whereas it carries the current, means here there is a load is connected to this one. Now this is one more type. It is a combined busbar CT is there, which is used for the LT panels. So it is 50 by 5 ampere. When the current flowing through this busbar is 50 ampere, the secondary of this CT is going to measure the 5 ampere. So this is for the R phase, Y phase, B phase, and this is one for neutral. So it is a single unit, 3-phase single unit CT is there, and this is individual phase unit is there. So there are different, there's a molded case CT is there, which can be used for the different applications. Now is a portable CT is there. Here this is acting as a primary winding. This acting as a primary winding, the single conductor, whereas this ring is acting as a secondary winding with a large number of turns, and with the digital display we can measure the current very easily and portable. So by opening this place with the help of this arm, we can insert in R phase, Y phase, B phase, or somewhere. So this is for the only LT type, not for the high voltage circuit. It is for the low voltage circuit. We can measure the current, and it is called as a clamp on ammeter, because we are going to clamp into the different phase or different cable lead of the cable, and hence it is quite easy to measure instantaneously. Sometimes it is not possible to connect permanent CTPT for measurement of current or indication of current. Therefore, we can use the portable type, current measurement with the help of clamp on ammeter. This is HTCT. HT type means 11 kV. It is say 11 kV CT is there, where the primary 11 kV line is connected here. One is the incoming side is the 11 kV, and here it is outgoing side. Again, it is a 11 kV. Whereas this terminal box comprises of secondaries terminal S1 and S2. This is P1 and P2 for the primary side. Similarly, this is 33 kV. The difference is that there is an insulator. Here the insulator length is small, which is sufficient for the 11 kV, whereas for the 33 kV, the insulation or the insulator from the metallic structure and high voltage side should be high. Therefore, we can see here, this is the outdoor type CT is there, and it consists of insulator with the higher length. So again, this is one primary side, P1, P2. Say this is P1 and this is P2, where it is connected to the 33 kV line. And again, it is outgoing is 33 kV. Whereas there is a terminal box, where in the terminal box we can connect to the measurement devices. Either it may be a watt meter, energy meter, or it may be the relay for the protection purpose, where the secondary is 5 ampere or 1 ampere. So it is HTCT, high voltage circuit current transformer. It is for use for the outdoor purposes. Now there are different outdoor purposes CTs are there. This is again 132 kV. It may be a 33 kV, 132 kV. This is a single unit, comprises of all three phases. Whereas it is HTCT, but it is an indoor type, which is used in the indoor application like cubicle meter. Generally, we will see there is a single unit where it is comprises of CTs and PTs. So this is CT. This is primary terminal P1, P2, and whereas from here side, this side, we can get a secondary of 5 ampere. This is again 11 kV side, and this will be these two terminals are for the secondary side. So this is one different kind of different shape as per the application, as per the housing or cabinet which we are using for the indoor application. Either it may be some square type, it may be a ring type. We can use the CTs. Now potential transformer. Why we are using the potential transformer? Again, the voltage, it may be 11 kV or 33 kV. This 33 kV voltage cannot be measured with the help of our ordinary voltmeter. Therefore, the voltage is going to step down to the manageable level. So it's just similar to the transformer, where primary winding is connected to the 33 kV, whereas the secondary voltage is 110 volt. So here the voltage is stepped down 110 volt. That is sufficient, or that is possible to measure with the help of voltmeter. So here, this is the application. So see, this is the 132 kV. Again, for the 132 kV, the length of insulator is large, whereas for the 33 kV, the length of insulator will be small, because it has to give the insulation level up to the 33 kV and 132 kV. It has only one terminal. So in case of, if you are going to visit in any substation, we can easily differentiate which is the CT or PT. Either it is a CT or PT. In case of CT, there are two terminal. One is incoming and second is outgoing for the load side. Whereas for the PT, only one terminal is there and secondary terminal is grounded. So with the help of number of terminals in the PT, PT and CT, we can identify either it is a CT or PT. Now, actual figure where it is connected. So see here, this is the one terminal is there on the top, isn't it? This is C. This is very clear. Only one terminal is there, only one terminal is there, so it is a PT. Whereas this one, it has two terminal. One is incoming side and second is outgoing. Similarly for this one, this is incoming, this is outgoing. So it is CT and this is PT. So in this way, we can understand in the substation which equipment is CT or PT. So this is the, say, different instrument transformers which we are using in the substation for measurement of voltage, current, energy, and actual figure of CT and PT, those are mounted or those are installed in the substation. So thank you very much. In the next lecture, we will see the cables in the LT side as well as HT side.